Welcome to the lesson on determinants and inverse matrices. In this lesson, you will learn how to find the determinant of a 2x2 matrix, find the inverse of a 2x2 matrix, and determine if a matrix is invertible using determinant. Now let us consider a 2x2 matrix A here with the given entries A, B, C, D. The determinant is denoted by det A, or just using straight brackets for the matrix. To compute for the determinant, all you need to do is get the product of the diagonal entries here minus the product of the other diagonal entries. So therefore, the determinant of this given matrix A here is just equal to the product AD minus the product CB. For example, what is the determinant of the 2x2 matrix B below? To compute for the determinant, we use the notation D, that B is equal to this, then we list down or use the straight line bracket for the matrix. And then we get the product of the diagonal entries here, 1 times 8. So that is equal to 1 times 8 minus the product of the other diagonal entry, 3 times 6. So therefore you have 1 times 8, so that is just 8, minus 3 times 6, which is 18. So minus 18, so the answer is negative 10. That means the determinant of the matrix B here is equal to negative 10. Another example, what is the determinant of the 2x2 matrix B below? To get the determinant, we are just going to list down the determinant of B, list down the elements of the matrix B, and then use this straight line bracket. So we have negative 2, 1, 3, negative 3. Then the determinant is just the product of the diagonal here minus the product of the other diagonal. So we have negative 2 times negative 3 minus 3 times 1. This is equal to 6 minus 3, and that gives us 3. Therefore, the determinant of matrix B is equal to 3. Next, we'll learn to compute the inverse of a 2x2 matrix. The inverse of a 2x2 matrix is given by the formula here. So we have 1 over, this is just the determinant of this matrix A here. So that is AD minus BC. Or in other words, 1 over the determinant of A times, and then look at this formula here. This is just this matrix, but this diagonal here is negated. So you have negative C, negative B. And then these two entries here are interchange. Let us illustrate this by finding the inverse of the given 2x2 matrix here. So A inverse is equal to 1 over the determinant of A times the matrix. So this same matrix here, but the diagonal entries here are interchange. So you have 3 and then 1 times, and then you negate the diagonal entries here. So negative 2, and then the negation of negative 2 is positive 2. Now, let's compute first for the determinant of A. The determinant of A is the product of the diagonal entries here. So you have 1 over the product, so 1 times 3 minus the product of the two entries here. So you have 2 times negative 2, and then again times this matrix here. So we have 3, 2, negative 2, 1. Now the determinant of A, so we have 1 times 3, which is 3, minus 2 times negative 2. So this becomes negative 4, and there's a minus here, that becomes positive 4. So that is 3 plus 4. So 1 over 3 plus 4 is 7. So 1, 7 times the matrix here, 3, 2, negative 2, 1. Then you just have to multiply each element here by 1 over 7. So therefore the inverse is just equal to 3 over 7. That's the first entry. 2 over 7. And then the bottom one is negative 2 over 7 and 1 over 7. This is the inverse of the given matrix here. Let us consider another example. Find the inverse of matrix A given below. So the inverse A is just equal to 1 over the determinant of the matrix, so determinant of A, times, and then we form the new matrix by interchanging these diagonal entries here. In that case, that is, both of these are just 1, so you'll just have 1, 1. And then after that, you negate the entries here, the entries of the diagonal here. So this negative 2 here becomes positive 2, and the positive 2 here will become negative 2. So we have 1 over the determinant. The determinant of A, the determinant of this matrix is just the product of these diagonal entries here. So 1 times 1 minus the product of the other diagonals or diagonal entries here. So again, 1 times 1, which is 1, minus the product of these two entries here, negative 2 times 2, that is negative 4. Times the matrix that we just formed, times this matrix here. 1, negative 2, 2, 1. All right, so this determinant here, this 1 minus negative 4 is equal to positive 5. So you have 1/5 times the matrix here, 1, 2, negative 2, 1. Next is to just multiply each element here by this scalar or by the number here. So you have 1/5, so that is 1 times 1/5, and then negative 2 times 1/5 is negative 2 over 5. Then 2 times 1/5, that is 2/5, and then 1 times 1/5 is 1/5. This matrix here is the inverse of the given matrix here. To determine whether the given 2 by 2 matrix is invertible, first let us consider the formula of the inverse of a matrix. Notice that in the formula, the denominator here is just the determinant of the given matrix. Now, since this is in the denominator, this one cannot be equal to 0. That means that if the determinant of the given matrix A is 0, then the inverse cannot exist. That would then imply that if you're going to look for the inverse of a matrix, the first thing that you should do is to determine the determinant of the matrix. If the determinant is equal to 0, the inverse does not exist. If it is not equal to 0, then the inverse exists. And then you can proceed to compute for the inverse of the matrix. So to illustrate this, let us consider the example here. Given a 2 by 2 matrix, let us determine if the matrix is invertible. To do that, we just have to get the determinant of the matrix. The determinant of this matrix is 1, 4, 1. That is just equal to the product of the diagonal entries 2 times 1, minus the product of the other diagonal, 4 times 1, the other diagonal entries. So 4 times 1. That gives us 2 minus 4, which is equal to negative 2. Now, this is not equal to 0. So therefore, the matrix here is invertible. Another example, determine if the matrix A is invertible. To do that, all you need to do is compute for the determinant of the matrix A. And then if the answer is equal to 0, that means that the matrix is not invertible or the inverse does not exist. So the determinant of the matrix A is just equal to the product of the diagonal entries here, 6 times 6, minus the product of the other diagonal entries here, that is 9 times 4. 6 times 6 is equal to 36, and 9 times 4 is also equal to 36. That it gives us 0. So since the determinant is equal to 0, that means that the matrix is not invertible, or the inverse of the matrix does not exist.